welcome. Thank you for joining our WSP Snack and Learn webinar, where we're going to be talking about powering your zero-emission fleet, choosing between battery electric and hydrogen fuel cell vehicles. So I'm going to go through a handful of slides here, and then importantly, there's going to be a Q&A session at the end. And the way to enter your questions is through the GoToWebinar chat box. You feel free to type them in anytime as you're thinking of them, but we will go through those at the end. We'll get through as many as we can, and we'll also try to make the handout available as well. It might be some nuggets that you want to share with other folks. So I hope everybody has your snack ready to munch on. Let's get started. All right, my name is Mike Finnern, and there we go. I am the National Alternative Fleet Vehicle Lead for WSP. I've been doing this kind of thing, deploying zero-emission vehicles and working in alternative fuels and this sort of technology for really well over 20 years. So I've got a lot of experience, helping to figure out, what works, what doesn't work, and making folks ultimately have a successful deployment. So hopefully you have a chance to gain some nuggets of information here. All right, so we're not going to spend a whole lot of time on this particular slide, so don't worry, about absorbing all of it now. But if you're a fleet operator and zero-emission vehicles is on your mind, you likely have a lot of questions. So the goal here today, my aim, is to answer some of those, and maybe more importantly, I'll give you some tips on kind of what next steps might be. So there's really two technologies for true zero tailpipe emissions. That's battery electric and fuel cell electric. I don't like to call them competing because it may be that both are the right answer in a lot of applications. But we'll kind of go through some of the things that are on this chart here in a little bit more detail. So what kind of fleets are we talking about? Well, there's a lot of them. In fact, there was a question from one of the participants about what sorts of vehicles we're going to be talking about here. You can see some of them on the screen. We're mainly going to be focusing on kind of medium and heavy duty applications, less so light duty or automotive, and that's because a lot of fleets are made up of these sorts of vehicles, especially those that are where there's an interest in transitioning to zero emissions. So there's a bus in the upper left, and that's important because really transit has kind of led a lot of this for a long time. They've been deploying zero-emission buses for really well over 15 years, and that's both battery and fuel cell vehicles. So a lot of experience has been gained over the course of that time, which is now transferable to other segments that you can see on here. And those other segments are really catching up quite quickly. So if you're like me, a delivery van of some sort, a step van, drives in front of my house what seems like 3 times a day. So that's a huge segment and really a good segment for transitioning to zero emissions. Then you have things like freight, class 6, 7, 8 type vehicles. And that's an application where perhaps more range and more onboard energy storage is beneficial. School buses are unique. They've got a unique duty cycle where oftentimes they go out in the morning, at least in the US, they go out in the morning for their student run to deliver kids. Then in the afternoon, they pick them up and they might sit during the middle of the day. And oftentimes they sit all summer long as well when school is out. Ports are a great application for zero emission equipment. You see a container handling forklift there. There's drayage trucks. There's a lot of ground equipment that has electric or fuel cell options now. And then even the vessels themselves. An interesting thing about ports is they tend to have a very regulations tend to be very international, so less local in terms of what's governing how they operate. Oftentimes there's very international regulations there, which I think is good. And then airports have a challenge. It's hard to come up with zero tailpipe emission airplanes, although smaller ones are certainly starting to exist. But from major commercial airports, you're really looking at ground equipment and supporting equipment like that. So we'll talk a little about those. All right, so vehicle technology. So focusing again on the kind of broadly speaking here, right? Really, it's applications specific, but broadly, if you look at the graphics, a battery electric vehicle has some kind of large onboard high voltage battery, and that battery provides power to an electric powertrain as well as accessories like HVAC and cooling systems and air compressors, for example, hydraulic systems perhaps. And then if you look at a fuel cell vehicle, it has kind of all that same stuff with a slightly smaller battery, but then add on top of that hydrogen fuel cell and some sort of onboard hydrogen storage. It's easier to store more energy in hydrogen on a vehicle. So that means when you look at the range there, I didn't put numbers on any of these things on purpose because it is very application dependent. But broadly speaking, you can put more energy in hydrogen on a fuel cell vehicle. So therefore, it's easier to have a little bit longer range or longer operating time with that vehicle. You can also fill the hydrogen storage tanks faster than you can typically charge a large high voltage battery. So that might be 8 to 20 minutes of fill time versus 30 minutes to 4 hours for a battery electric vehicle. So it's really pretty similar to fill times for a diesel or a CNG type vehicle, for example. A fuel cell vehicle, broadly speaking, is going to be a little bit more expensive, and that's because if you just look at the images, there's more stuff. You have all the same electric drivetrain and accessories, and then you add on top of that for the fuel cell vehicle, the fuel cell itself, and the hydrogen storage. So that adds cost and complexity. Now, there's a little bit of an offset in that you can have a smaller high voltage battery, but broadly speaking, a little bit more complex, a little bit more expensive for fuel cell vehicles. And battery electric vehicles are more available, although I will say fuel cell vehicles are catching up. I was at a recent show out in California, and there was a lot of fuel cell vehicles available, people that were demonstrating them there. So they're catching up. That's filling in terms of availability. All right, so let's talk about the energy source. So we'll start with electricity. Generally speaking, you've got broken down into kind of 3 sections. You got generation, transmission, and distribution. And one of the kind of neat things about the electrical grid is what's known as fuel arbitration. So there's lots of different sources generating electricity at any one given time, and utilities can kind of arbitrate between those as far as what has the highest potential or highest contribution to the grid. And that's one of the reasons why electricity prices are typically fairly stable. They don't change a ton over time. The other thing that's interesting about electricity and the grid is that renewables are growing quickly in terms of the percentage that they're providing to the grid for the power generation. And what that means is if you have an electric vehicle and you're charging it from the grid every day or routinely, then your vehicle itself is actually getting greener over time as well, because the grid itself that's powering it is including more renewable sources and whatnot. It's also worth noting that when you talk about installing a lot of chargers for a fleet application, maybe at your yard, typically the bottleneck is the distribution side of it. It's not generally that there's a lack of generation or transmission capability. It's more a challenge with actually getting it locally, the infrastructure that's actually local to your facility. That tends to be the bottleneck. All right, so let's talk about hydrogen. Hydrogen, I thought I'd do a little bit of a broader overview just because it may be something that's a little bit less familiar to folks. You've no doubt heard about the colors of hydrogen because there's a lot of sources of hydrogen. You can generate hydrogen in quite a number of ways. So folks have decided that we should apply colors to those. My suggestion is if greenhouse gas emissions is really your goal, you're concerned about that, which is the case. That tends to be a goal and a reason why people might transition to zero-emission vehicles is greenhouse gas reduction targets. If that's your goal, instead of thinking about it as colors, think about it as carbon intensity, because that's an actual measurable parameter for your hydrogen source. Because really, you can get it from a bunch of different places, and it could be mixed. So think about mixing all those colors together. That's the way to think about it. A lot of hydrogen in the US, and I think it's true generally worldwide, like the vast majority right now, is produced from steam methane reformation. So it comes from natural gas, because there's a lot of industrial processes that use a lot of hydrogen today, notably fertilizer production, steel production, industrial processes like that use a lot of hydrogen, but it's not necessarily hydrogen that's pure enough for fuel cells, for example. So getting the hydrogen that you want at the purity that you need for fuel cells is one of the challenges with that type of vehicle and that type of zero emission fleet right now. All right, so a little bit more on hydrogen. Here's kind of an image of available options for fueling your hydrogen fuel vehicle. So think of your vehicles in the upper right. You've got a dispenser that looks very much like a gas or CNG dispenser that you're used to. You got some local on-site storage, and then you're gonna get the hydrogen in a few different potential ways. If you have a small fleet, gaseous delivery, which is high pressure tube trailers, is probably the best option. That can be done pretty quickly, pretty easily, and relatively inexpensively. But hydrogen, as everybody remembers from high school, is the lightest molecule, and it's hard to get a significant quantity of hydrogen, especially in gaseous form. So you don't get much of it in that way, and it's really only suitable for maybe 2 to 5 vehicles. If you have more vehicles than that, much more common is to receive hydrogen locally in the liquid form. So liquid hydrogen is simply hydrogen that's been liquefied, which of course adds cost, but as you can easily see, you can get a lot more of it on site. You can store it much more easily in much higher densities. There is a challenge with liquid hydrogen in that if you still have a relatively small fleet, if you're just starting out, there's a phenomenon called boil off. Every time you start up your fueling system, you add heat into the system, which does have the potential to kind of boil some of the liquid hydrogen into gas in a way that isn't usable within the vehicle. So it can be a factor, a pretty significant factor, if you're just getting started. So something to consider. It's less of a problem, and there's plenty of mitigation, possible design changes and whatnot to mitigate that as you kind of increase volume. And then you could also produce it on site. There's kind of less than industrial scale electrolyzers or steam methane reformers. Of course, in those cases, you still need to have electricity. The electrolyzers take a lot of water, for example, or if you're doing steam methane reformation, you need a pretty significant source of natural gas, and then all the compression equipment that goes with that. But that is an option, and it's growing in popularity. All right, so what are some of the other considerations beyond fuel and the vehicles themselves? Here's a couple of them. Workforce development. I really can't stress this enough. No matter what you are intending to do, no matter what your path forward is, and even just for any new technology, right, beyond kind of what we're just talking about here, you got to think about workforce development. And that means employee engagement through all elements of your operation, early and often. And having done this a lot, I can tell you that this is probably the biggest factor in success of a project, is making sure you get out in front of this new change, right? That's going to impact people on a day-to-day basis. Make sure they're comfortable with it and are trained up on it. Resiliency. So this is certainly something to consider. Take transit as an example. Oftentimes transit is a part of emergency response plans for their local community. So think hurricane evacuations, for example. Oftentimes transit is a big part of those plans. So you need to consider resiliency. So what if the grid goes down? How are you going to handle that? And here again, in both cases, battery electric or fuel cell, there are various options to help with resiliency. You can create your own microgrids, which is actually becoming quite common now. A lot of data, the technology is advancing there in a lot of ways because of the data centers that are popping up everywhere, like these AI data centers need a lot of uninterruptible power, high resiliency, and so they're creating their own microgrids. There's on-site storage, etc. A lot of ways to address that, depending on the technology you have, but something to consider. And then facility upgrade potential. So if you store vehicles inside or work on them inside, which is quite common, and you want to implement hydrogen, you need to make sure that your facility is up to code. So you have a lighter than air fuel. You need to be able to detect that and have appropriate ventilation for that. So there's upgrades necessary. And then a fueling station for hydrogen has setback requirements. And so you got to make sure you have space for it. Where are you going to put that? And there's ways to mitigate, some of the setbacks. If you don't have a ton of space, you can build walls and whatnot to contain, potential incidents, but nonetheless, something to consider. And conversely, if you're interested in electricity, it's a really big point. You got to spend some time understanding how much power you're going to need and how are you going to get it into your facility. That oftentimes means working with your utility. And then the chargers, where are you going to put them? And are you going to lose parking density, for example, because of installation of charging dispensers? So some key considerations there. And it all kind of boils down to cost, right, at the end of the day. So the chart here on the right is purposely ambiguous, really because it's situation dependent. For example, battery electric vehicles are less expensive, but they may not serve all of your long distance needs. You may need more than one-to-one replacement, for example. That could drive up the cost. Charging infrastructure is typically cheaper, but if you have a lot of power needs, a high power need, and your facility is old, it may be difficult to get all that. So you need to work with your utility. That can drive up cost and certainly extend the timeline. Conversely, fueling infrastructure might be expensive initially, but it could be cheaper long-term, especially if you have challenges getting power to your site for charging, for example. The big question, which is why it's in bold, is how much will the hydrogen itself cost? That's a big question and a big challenge right now with converting to fuel cell, is coming up with a source of hydrogen and understanding its cost. The key here is you got to spend time early on modeling your energy needs. Take the time to do a thorough analysis early to model how much energy you're going to need to satisfy the operation that you have today. And that's really the foundational data set that's going to go into that analysis to figure out what option may be best. And it may be that both options are best, right? You don't necessarily have to choose one over the other definitively. All right, so let's look at a case study. All right, so this is a case study that WSP did to answer this specific question, BEV or fuel cell. This is for a transit agency, a pretty big one. They have a goal to transition their full fleet to zero emission, and they have some specific challenges. Long routes, fairly long routes in some cases, but probably bigger than that even is old facilities with limited access to power. It was hard to get enough power to some of their facilities. So we did a very thorough analysis, and you can see on this graphic on the right, if you see a bus in the box for that particular parameter, that means it's more favorable. So range and refueling, that favors fuel cell. Costs on an individual basis favors battery electric. But the reason I keep saying this is you really need to have a big picture, holistic, thorough review is because there could be one particular element that drives you in one direction or another. And in this case, it was the challenge of getting all the energy that they might need into all their facilities. It really was a roadblock. So that row for scalability, in this case, really favored fuel cell in this particular case. So what did it actually cost? Well, here are some numbers. And, it's, again, this is one particular application. Because of the challenges that I mentioned, the lower vehicle cost was outweighed by the higher charging infrastructure costs. So in this case, fuel cells and hydrogen fueling infrastructure was quite considerably cheaper. But the big but is now they got to find hydrogen. So this is a study at this point, and so there's time to do this, but it is not an insignificant challenge is now to find the amount of hydrogen they need. So things like partnerships and working on things that we refer to as hydrogen hubs is part of that effort. All right, here's the big takeaway though. It's an ecosystem. It used to be you could maybe buy, if you were just getting more of the same vehicle, you could buy more of them, drop them into the operation seamlessly, no big deal. But when you're changing technology, you need to do it a little bit differently. You need to get your entire organization involved very early on. It's going to impact every element of your operation. They need to be involved right from the start so they can help, they can understand it, and they can make it go smoothly. There's a lot to it. So utilize knowledgeable partners. it's really not possible to be an expert on everything, and you need to have people that can help you answer the right questions. If you get foundational information wrong or foundational assumptions wrong, it could screw up your whole analysis. And then really importantly here, again, based on a lot of experience that I have, think of it as continuous improvement, right? You're not going to replace everything all at once. You're going to do it over time. So have a good plan for the future, but start relatively small, get a feel for it, and plan for challenges. You're going to have challenges. You need to make sure your organization is aware they will face challenges, and you can get past those if you do it properly and plan for it ahead of time. And the way to get through challenges is to have champions within your organization. Those are the people that really want it to be successful, and we like to feed them as much information, as much training as we possibly can. And what ends up happening is they make these projects successful, and they spread that success within organizations. So that's really the way to think of this as an ecosystem. So I said we'd go back to this chart here. Hopefully you can maybe kind of absorb a little bit more information from it. I'm not going to read through it, but depending on how you're applying these sorts of vehicles, one of these elements might favor one technology over the other, but it's all relevant to how you're going to be using these things, and what vehicles, what infrastructure, what facilities do you have available now, and then where do you want to go? What are your goals? And importantly, as I mentioned, I don't consider these to be competitors, because it's possible, even likely in a lot of cases, that both solutions will ultimately be necessary to get to your long-term targets. The other thing I'll mention on this is we're still early in the maturity curve for both of these technologies, and so they improve quickly over time. And so just going back to my comment about starting small and then having a plan and then continuously improving that over time. Batteries are getting better, fuel cell vehicles are getting better, sources of hydrogen are getting better. So your ultimate solution may change over time. All right, in conclusion, it's really dependent on how you're operating, what your operation looks like, but both are options and readily available today. You can start on either of these in most cases today. You've got to start with a thorough plan, which you have to do an analysis on your specific application, and that really starts with modeling the energy requirements for your vehicles. We've got a tool that we use called Bolt for that. And I'll say it again, engaging your workforce early and often is probably the biggest driver of success, no matter which direction you go. And think of it as an ecosystem, and find some experienced partners to help. That's all I've got. I will, get over to questions. If I can figure out how to do that. There we go. Sorry about that. So yeah, type in questions if you have them. We've got a few of them here. Okay, so a couple questions related to hydrogen. So I'm going to paraphrase a little bit on this. If more energy can be stored on hydrogen vehicles, why is it not getting more traction? Well, I think it actually is. So you got to think about these technologies in terms of what makes the most sense for different applications. So I mentioned I was at a show recently. Vehicles like Class 8 trucks, long haul trucks, they have to go a long ways. There's getting to be a bigger and bigger push for fuel cell, because you can put more energy on board. There's other applications where it doesn't make any sense, and therefore people aren't putting any effort into it. So there is actually quite a bit more push in those particular areas. This is maybe a good question for a number of these things here. So where will hydrogen energy go from here? And what's the future of hydrogen energy? Yeah, so there's a lot of people that study this stuff, and the way I like to think about it is the way I like to look at it is the vehicle OEMs, especially like the big vehicle OEMs. They have a lot of folks that investigate, analyze the market, try to figure out what do people want, what's the best approach, what's cheapest, et cetera. And it really boils down to looking at each application. Amazon delivery vehicles that drive around a local town, that probably makes sense to make those battery. You probably don't need to have the added expense of fuel cell, for example. But like I already mentioned, long haul trucks, probably makes sense to be able to put more energy on board in the form of hydrogen. That might make sense for those applications. So I think there's going to be a future for both. One's not going to win overall, for example. You're going to see both, and they're going to kind of naturally matriculate into where they best fit based on the factors of their benefits to the environment, but probably more honestly cost, right? What's the return on investment? What's the total cost of ownership? What's the average cost of a fuel cell passenger vehicle? Well, so passenger vehicles are interesting. There has been a handful that have come out, Honda, Toyota. Honda actually is just out with their fuel cell CRV. I think it's a CRV that has like their Gen 3 fuel cell in it. And there's a lot of development in that fuel cell. The way they're doing those now is really on a pilot basis. So they're leasing them. So it's it's effectively a subsidized price. So I couldn't really give you an honest answer of how much they cost because they're really at the pilot stage of deployment. Cost, have you noticed a significant difference in the cost of hydrogen in different states? For sure. The cost of hydrogen can vary significantly depending on where you're getting it from. So today, if you really need green hydrogen, for example, low carbon intensity hydrogen, you may have to put that on a truck and drive it halfway across the country, just about in the US, right? There isn't a ton today. There's quite a bit of hydrogen production in the planning stages. And so that's why I mentioned you really there's a little bit of a crystal ball element to hydrogen. There's a lot of goals. The government has set out goals and other agencies have set out goals for the cost of hydrogen to drive it down to be equivalent to diesel, for example. But that stuff's out into the future. So, plan for that. Oh, I like this one about applicability of the two technologies in harsh winter conditions. That is a good one. And that's another reason, another factor, when you're deciding between the two. I think it's probably no secret to folks that are on the call like this that battery electric vehicles are a little bit more challenged in cold weather climates. And that's because you got to use the high voltage battery to generate the heat that you need for the vehicle, both to heat up the battery itself and the cabin. And that just takes a lot of energy. So there's improvements in that with heat pumps and whatnot. And there's ways to mitigate it with what we refer to as preconditioning. So making sure that the vehicle's up to temperature while it's still connected to the charger before going out on the road. But that can be a challenging situation where range can drop significantly. And fuel cells are better in that regard. So they tend to be a little bit better in harsh winter conditions. And we are at the end of time. There's a couple of questions, and I apologize I didn't get to them all. But I really appreciate everybody joining. Thanks so much. My email is on here, and those of you, if you sent a question and I didn't get to it, take a screenshot here, send me an email, and I'd be happy to get back to you with an answer to your question. So I really very much appreciate everybody's time, and I hope you have a great rest of the day. Thank you.